Hello and welcome. This is Matthew Raymer of RTFM Training at your service for the next few minutes, introducing injection vulnerabilities. Injection, in its many manifestations, is public enemy number one on the OWASP hit list of top 10 vulnerabilities. Today we walk through some of the more prevalent and dangerous kinds of injection. I aimed at taking the best authorities I was able to find and reading their contents claim carefully so as to digest their wisdom here for you. My emphasis aims at clarity of explanation and, as far as space permits, giving you a stepped exposition of surrounding circumstance to the kinds of injection. So we head on out together now to explore this electronic world of skullduggery and intrusive deceptions. Injection attacks refer to a broad class of attack vectors. It can come from a variety of directions, ways, and intensities. There can be, for example, in-band, wherein data is extracted by use of the same channel that is used to inject the code. In-band is the most straightforward kind of attack wherein the data retrieved is presented directly in the application. Then there are out-of-band attacks wherein data is retrieved by use of a separate channel, such as via an email, and the results are generated and sent to the attacker. Note, the term in-band is a term used in telecommunications, and the term here has been transferred over for use in security matters. Within the telecommunications industry, in-band denotes the sending of control information within the same band or channel that is being used for transferring data, such as voice or video. This in-band approach is in contrast to using out-of-band signaling, wherein data is sent over a separate channel or even uses a separate network. In-band telecommunications signals may often be heard by telephony participants, but out-of-band signals are inaccessible to such users. Then there is inferential injection, and here no actual receipt of data, but instead the attacker is able to reconstruct the information. The tester does this by sending particular requests and by him or her observing the resulting behavior of the application. Stated generally, in an injection attack, an attacker intrudes untrusted data to a program. By untrusted data, I mean any data that comes from input and which is thereafter applied to software. In addition, the software may assume wrongly what the data is supposed to look like. In other words, it may not discern the fact that there is missing, incomplete, and supplemented data. Ultimately, this means that the software developers had assumed how users are typically going to act. On the contrary, attackers will act atypically in order to cause damage or to get information. But developers alone are not the only fall guys to take the whole rap here. There are project managers, planners, architects, and a whole food chain where these flaws can find their roots and diversify blame. It could be you. An attacker enters an amount of data which does not fit with the expected or assumed input. Thus, the input malforms this data. And when its directions are executed, it will have perhaps drastic consequences unintended by the guys in the organization concerned. Recall that list I made. This malinformation can also lead to error leakage from the system and damage to system data. Such occurrences would constitute integrity violations. Or else, such exposure of data would perhaps cause confidentiality violations. Note, confidentiality is a component of privacy, particularly the protection of data from unauthorized viewers. Integrity and confidentiality are two legs of what is frequently called the CIA triad: confidentiality, integrity, and availability. Be aware that after having made a successful injection attack, an attacker may well be able to do anything with the application that it is capable of. Note, injection doesn't have to be malicious. It can be done or occur by accident. But accidental injection generally results in an error rather than it exposing a vulnerability. The harmful content injected also doesn't have to come from a user. It can be content that your application receives from any source, or even content it has itself generated in code. We need to understand that an attacker is able to bypass any client-side controls that we might set up with an intent to remediate the vulnerability. For example, if you use JavaScript validators, these are not enough to be a preventative, but an attacker will bypass anything that subsists in the browser. This ability to bypass is particularly significant in regard to the modern idea of front-end frameworks. These would be frameworks like Angular and React applications. These execute in the browser, while in the backend there is only an API. This setup means you've got to be really careful that the API at backend is not making mistaken assumptions about the data coming back from the browser front end. But let's get back to the idea of injection in general. There are several variant means for exploiting an injection vulnerability. These might include, but should not limit to things like code, CRLF, XSS, HTML headers, LDAP, OS commands, SQLI, or XPath. I'm going to constrain this current lesson to SQLI, SQL injection, and I am leaving to future lessons explorations of the others. Note, SQLI is generally considered to be solved as a vulnerability, but nonetheless it persists as an issue. We'll explore in a later lesson this robust persistence and look at some of the various reasons for SQLI remaining at the top of the OWASP vulnerabilities found in web applications. There have been classified several forms of SQL injection, starting with in-band injection types. There are error-based injection, which is where an attacker sends a malicious query to the database and this results in errors arising in it. These errors should be couched by developers in terms as generic as is practicable. Otherwise, they are likely to offer useful informative hints to an attacker. The attacker is able to improvise logically incorrect queries which investigate the error messages, and so he may get more information about the target database. Note, I'm using SQL queries in most of my examples, but do bear in mind that an attacker will not normally make a direct SQL query to the database. His SQL queries then will be more so the end products of other attempts, like for instance him filling in an input box on a page with a string before him attempting injection. The above query will result in a syntax error due to the single quotation mark at the end, and this error might reveal to an attacker the backend database type. Then there's an action where an attacker converts a portion of a query into a comment by adding a comment symbol. This is called comment injection. Doing this type of injection causes a database to ignore part of an otherwise valid query. For example, in this query here, an attacker has made it so that all information coming after the double hyphen symbol will be neglected by the SQL interpreter. In effect, a condition which would have required the role of a user to be an admin was ignored. We move on. There are also tautology injection types. These are where a number of strings default to evaluating as true. Examples are 1 equals 1, A equals A, etc. An attacker will use these strings in his or her query and so create constantly true conditions. In the example I give you, you can see how usage of tautology and comment injections by an attacker has converted the password credential field to accept any word at all. Now we look at union injection types. Under this header, an attacker might use a union command in an SQL query to execute additional queries. And thereby he modifies, inserts, deletes, or drops the contents of, say, a table. Note, a union operator acts to combine the result set of two or more select statements, so that one finds an attacker, by his use of the union operator, has added an amount of data to a command and so broadened it beyond what it was intended to do. In a worst case, he or she gets access to the whole shooting match. Inferential SQL injection is a kind that is unlike in or out-of-band SQLi. By its nature, it may take longer for an attacker to exploit you by him using this. However, it is just as dangerous as any other form of SQL injection. An inferential SQLi attack involves no data actually being transferred via the web application. An attacker would not be able to see the result, as he would see one if it were an in-band attack. This is why such attacks are sometimes referred to as blind injection attacks. With an inferential SQL injection, an attacker is able to reconstruct the database structure by sending payloads. These payloads, as it were, listen for null responses in the web application, and by these omissions, the attacker can learn about the behavior of the database server. This blind type of SQL injection doesn't allow us any clue as to whether the web application has been violated by injection attack or not. An attacker acts by asking the DB a true, false, or Boolean question, and then he can use the reply, which will state whether a valid page has been returned. Or else an attacker might use knowledge of the time span or delay it took to have a valid page returned. This knowledge gained might add to that had from the answers to his questions. Let's show an example which is more like an injection attempt via a URL and what it actually looks like. This example is asking the application if it is running a SA account, MS SQL Administrative Superuser. Note, I'll discuss more real-world examples in a future lesson. Then there is a Boolean type injection, which is only useful for making correctly formatted and presented SQL queries. Such queries will always show a result. Boolean type injection queries, which are incorrectly made, return nothing, and so attackers using this type are constrained to attempt logically correct queries. Suppose the original Boolean query to the database had been, we offer blah, and then 1 equals 1 as input, which is evaluated by the system to be an acceptably presented query. By us using that Boolean query, we shall see user results. Now we offer blah and 1 equals 2 as our input, and this is a wrongly presented query, and we see no results arise. Time delay blind injection type is dependent on certain conditions being present. A time delay allows the input the attacker gave to produce a positive result, but to wait for this can be time-consuming. In web security work, time-based techniques are often used to make tests where there is no other way to retrieve information from the database server. The time-based attack type injects an SQL segment containing a specific DBMS, database management system, function, or else injects a query which similarly requires heavy processing and generates a time delay. Note, the segment operator is used to insert a segment column in a data stream. The segment column is a marker used to indicate the start of a new data segment. Segment columns are a set of consecutive columns having the same value. Segment columns are situated within one or more predefined columns, which are known as the grouping columns. There are other operators besides grouping columns that use segment columns to change their behavior. A change in behavior occurs whenever a new segment in the data begins. Thus, behavior changes occur whenever the data reaches, finds, or begins to fill out any new segment column. An example of this happening can be found in what is called the sequence project. This project resets its internal counters whenever new segments begin. There are in addition some advanced and more exotic forms of SQL injection. For instance, the use of SQL in tandem with JavaScript quines self-replicating programs when multi-step injections are being done. We'll have to reserve our discussions of such advanced topics to future lessons once we've got the basics out of the way. In our next lesson, we'll be focusing more so on diagnosis and remediation of SQLI. This has been Matthew Raymer of RTFM Training, taking you in measured steps through the fraught field of SQL injection, the OWASP community's top bad guy among its top 10 software vulnerabilities. So, if you are on board, I'll be offering similar topics in similar video manageable sized talks. Keep a lookout for me here. Till then, adios.